We would like to introduce the project on the Riemann hypothesis. The goal of the project is to understand the Riemann hypothesis. And in order to do so, we need to talk about the function zeta. Zeta is a function of one complex variable. It's defined everywhere except for the number s equals 1. It is analytic everywhere where it's defined. And as long as s has real part greater than 1, it is given by this formula right here. The Riemann hypothesis is simply the statement that if the zeta function is 0 at some number between that has real part between 0 and 1, so if we wanted to represent these numbers on the complex plane, they form a strip. Sometimes we call this the critical strip. So if at some point in this critical strip the zeta function is equal to 0, then that number for which the zeta function is 0 has to have real part 1/2. So the only zeros of the zeta function fall in the critical strip fall on the line which is perpendicular to the real axis at the point 1/2. Now, of course, at first glance, this seems like a very strange statement. Why would this be something that people would desire to know? And not only that, why would this be the single most important unsolved problem in all of mathematics? So to answer these questions, we will set some immediate goals. So we want, first of all, to talk about complex numbers, analytic functions that are the natural functions to consider over complex numbers. Then the statement of the Riemann hypothesis will be at least technically understood, but we will have to make a connection to the distribution of prime numbers in order to see a first indication of its importance. And we will also try to understand some equivalent, some statements that are equivalent to the Riemann hypothesis. So overall, we want to complete this project with a good understanding of what the Riemann hypothesis is all about, what the current state of the attempts to prove the Riemann hypothesis, or who knows, possibly to disprove it, even though most people seem to believe that it's true, and appreciate its importance in mathematics. And that's all for now.